Sequences are a set of numbers arranged in a definite order according to some definite rule. It is a list of numbers or objects in a special order. The term a sub n is called the general term or the nth term of the sequence. Here we have an example of a sequence. The numbers 3, 5, 7, 9, and so on shows a sequence with a common difference of 2. The symbol ellipsis shows that the sequence is infinite and there may be no end. Sequence is called finite if the number of terms are finite, meaning that there is an end to the sequence. There are 4 types of sequences: arithmetic sequences, geometric sequences, harmonic sequences, and Fibonacci sequences, which will all be tackled in this video.
The first type of sequence is the arithmetic sequence. This sequence wherein the differences between two consecutive terms remain constant. The fixed number is called a common difference. For example, the sequence 2, 6, 10, 14 is an arithmetic sequence with 4 as the common difference. Another example, the sequence 8, 5, 2, -1, -4, -7 is an arithmetic sequence with -3 as the common difference. A sub 2 is equal to A sub 1 plus D. A sub 3 is equal to A sub 2 plus D. A sub 4 is equal to A sub 3 plus D. Arithmetic sequence can also be given by this equation. A sub n is equal to A sub 1 plus n minus 1 times D. Here we have a sample problem. The first term of an arithmetic sequence is equal to 200, and the common difference is equal to -10. Find the value of the 20th term. Substitute the values given by the problem, which are the common difference -10 and the first term A sub 1 is equal to 200. Since the formula for finding the nth term is A sub n is equal to A sub 1 plus n minus 1 multiplied to D, first, subtract 20 by 1, which is 19. Then, multiply 19 by -10, then you get -190. Add 200 and -190, and the final answer is 10. So, the 20th term is 10.
The next sequence is the geometric sequence. Geometric sequence is made by multiplying by the same value each time. It is a sequence of numbers that follows a pattern where the next term is found by multiplying by a constant called the common ratio presented by R. The formula for geometric sequence is given by A sub n is equal to A sub 1 multiplied by R raised to n minus 1. Here we have an example problem. Write the first 5 terms of a geometric sequence in which A sub 1 is equal to 2 and the common ratio is 3. We use the first given formula wherein A sub 1 is equal to 2. Next, to get the second term, you multiply the first term, which is 2, to the common ratio 3. Which is equal to 6. Repeat the process until the fifth term. Therefore, the first 5 terms are 2, 6, 18, 54, and 162.
The third sequence is the harmonic sequence. The harmonic sequence is a sequence of real numbers formed by taking the reciprocals of an arithmetic sequence. The numbers are also separated by a common difference. One example of a harmonic sequence is the sequence 1 over 3, 1 over 7, 1 over 11, 1 over 15, 1 over 19, and 1 over 23. It is a harmonic sequence because its reciprocals 3, 7, 11, 15, 19, and 23 is an arithmetic sequence. For a simpler explanation, a harmonic sequence is the reciprocal of an arithmetic sequence. Example, in a sequence of 1 over 8, 1 over 26, and 1 over 46, find the 20th term. Get the denominators, which are 8, 26, and 46. We can use the formula 1 over a sub n is equals to a sub 1 plus the quantity of n minus 1 multiplied by d. Substitute the given values, which are a sub 20 is equals to a sub 8 plus 20 minus 1 multiplied by 18. 20 minus 1 and you get 19. Next, multiply 18 and 19. The answer is 342. Add 342 and 8, and the final answer is 350. Substitute the value of 350 to the denominator and the final answer 1 over 350. Therefore, the 20th term is 1 over 350.
Fibonacci sequence. Fibonacci sequence is a sequence of number in which each successive number in the sequence is obtained by adding the two numbers in the sequence. The sequence is named after the Italian mathematician Fibonacci, which is Leonardo Pisano of Pisa. Looking at it, you can see that each number in the sequence is the addition or sum of the two previous number. For example, since we start with 0 and 1, we wrote here 0, 1. In able to get the next number of terms, we simply add 0 plus 1. We can solve Fibonacci sequence by using the rule method. Sequence usually have a rule. It can be another way to find the value of each term. But first, we will make a table. The formula for rule is x sub n is equals to x sub n minus 1 plus x sub n minus 2. For example, in Fibonacci, we will compute the term 9 by replacing the n as 9, so it would be x sub 9. By following the rule method, it would be like this. X sub 9 is equals to x sub 9 minus 1 plus x sub 9 minus 2, which will be x sub 9 is equals to x sub 8 plus x sub 7. We will substitute x sub 8 and x sub 7 in Fibonacci term. So x sub 8 will be 21 and x sub 7 will be 13. X sub 9 will be equal to 13 plus 21, which will give you an answer 34. Fibonacci sequence can be related in nature such as plants. The number of petals is Fibonacci number. For example, the tulips and iris has 3 petals. The next plant would be the aloe plant. Fibonacci number can be also a spiral shape. It shows that the numerous cactus display the Fibonacci spiral. We can see how the leaves spiral outward. The next is sunflower. It shows that it has a complex Fibonacci sequence. Spirals on sunflower's face by counting it in clockwise and counterclockwise spirals that reaches outer edge.